Hi, today we are on the chapter of normal distribution. Now, what are normal distribution? Now, let me give you some example of normal distribution. One of them is the height of teenagers in Singapore. Another example is the amount of rainfall in a particular month, all right, for a period of, let's say, 100 years or 50 years. One of the characteristics of a normal distribution is that it is continuous. It is a continuous distribution. Now, if you know what is binomial distribution, now binomial distribution is discrete. All right, an example of binomial distribution is the outcome of throwing of a dice. Now, the outcome can be 1, 2, 3, 4, 5, or 6. Now, the outcome cannot be 1.1, 1.25, 1.3. So it has to be specific numbers, all right, 1, 2, 3, and there are gaps in between. So these are called discrete distribution. Whereas height of teenagers in Singapore, take for example, let's say the average height is 1.75. You find that you have 1.751, 1.7511, 1.629, 6295, there's no gaps in between. And for normal distribution, the population is always very large. All right. So let me just write down the first characteristic. It is continuous. Now, what is the second characteristic of a normal distribution? It is symmetrical about its mean. Now, what is the x-axis? This is a typical probability distribution function of a normal distribution. Now, what does the x-axis represent? The x-axis represents data. Take for example, like the average height of boys in Singapore or teenagers, all right? So this will be the height, okay? So maybe it range from 1.5 to 1.95. Now, of course, you will have even less than. Now, this represents the data of. Now, take for example of boys, the height of teenagers in Singapore. The x-axis will be the data, will be the height. Okay. Now, what is the y-axis? The y-axis is the probability. Now, you find that let's say at a particular height, 1.72, the probability is very, very low because it cannot be 1.721, it cannot be 1.723. Right? So these numbers here on the y-axis are normally very, very small, like 0.0008 or 0.02. All right, it's very, very small. But the whole area under the graph, all right, is 1. That is the total, because the total probability is 1. So for a specific value, you find that the probability is approximately 0 or close to 0. Okay. Now, a normal distribution is defined by its mean and its standard deviation. Now, standard deviation, the notation is sigma, whereas here is sigma squared. Sigma squared is the variance. Now, let's say the average height is 1.76, so mean is 1.76, and the standard deviation is 0.002. Okay. Now, the mean is the average. Then what does the standard deviation measures? The standard deviation measures how widely spread the data is. Let's say we take another example, all right? Let's say example of America. So maybe they are taller, all right? Their average height, you find that is 1.8. But they have a bigger standard deviation, so that is 0.1. So how will the graph looks like? Now their graph, because this is 1.76, so 1.8 will be somewhere here. Let's see, somewhere here. This is 1.8, right? And then because their standard deviation is larger, so their data are more widely spread. That means their curve could look something like that. All right, they are more widely spread. Okay, now this is the mean. Right, this is where it is symmetrical about. Now we will now go on to learn how to calculate the probability of a given normal distribution. Question 1. Now you're given that the random variable x has a normal distribution of mean 10 and variance 2 squared. You are asked to find the probability that x is less than 10. Now let us draw the graph, and this is the mean. The mean is 10 and the variance is 2 squared. Now what is the probability that is less than 10? That means the answer to this is simply 0.5. Because the graph is symmetrical about its mean, so anything less than 10 will be on this side of the graph. So the answer, the total probability is 1, so half of it will be 0.5. Now next question, what is the probability that is less than 13.5? So where is 13.5? 13.5, let's say, is somewhere here. You want the probability that is less than 13.5. So this is the probability that you want to find. All right. Now, if you use the GC, all right, you use TI-84. I'm talking more on TI-84. If you're in the IB, you are using the TI-Inspire model, but it's more or less the same. Now, if you go to your stat distribution, and then you look for normal CDF, all right, then you press normal CDF. So let me just write down. The calculator will prompt you lower limit followed by upper limit followed by its mean and its standard deviation. So you look at this graph, all right, you want this part of the graph. So the lower limit will be negative infinity, so you can just put minus 9,999. All right, you can put more 9s if you want, all right, okay, or some of you may put minus e to the power 99, all right. So upper limit, you just put 13.5, and your mean is 10, variance is 2. All right, that gives us an answer of 0.04006 approximately. Now let's move on to part 3. Now in part 3, you are asked to find the probability of x is between 7 and 11. Now let us draw. You want it to be between 7 and 11. 7 here, see 11 is over here. All right, so this is the probability that you want to find. Okay, this is 7 and this is 11. Now same thing, you just go to your distribution normal CDF, all right, then you key in, they will prompt you, all right, to key in the lower limit, the upper limit. All right, what is the lower limit now? The lower limit is 7, upper limit is 11, followed by its mean, which is 10, and standard deviation 2. and just key enter, and then what will your answer be? Your answer will be approximately equals to 0.6247. We will learn how to use the inverse normal function to find the value of the data such that if we are given an area of the probability. Now in this question, the random variable x has a normal distribution of mean 4 and standard deviation 5 or variance 5 squared. Find the value of a such that the probability of x less than a is equals to 0.1. Now I think first of all you must be able to see where a is, whether it's on the left of the line of symmetry or on the right of the line of symmetry. Now you want less than a to be 0.1. So a will be on this side of the bell curve. So this area is 0.1. Now why is it this side? Now if a were to be on this side, you will find that it is more than 0.5. So a must be on this side of the curve. Now let me just copy it down. P of x less than or equals to a is equals to 0.1. Now if you are using the TI-84, you just go to the distribution option and you select inverse normal. Inverse normal. Then they will prompt you, alright? The first thing they prompt you is the error, followed by the mean and the standard deviation. So you just need to key in. So inverse normal. The error in this case is 0.1. And then the mean is 4. Standard deviation is 5. Now after that, you'll find that they will ask you to find the location of the error. Is it on the left hand side of the bell curve or on the right or in a certain interval or the center? So in this case, it's on the left. So you select left. Okay. And then you press enter twice if I'm not wrong. Okay. And then you will get this answer of negative 2.41. Now let's move on to number 2. Number 2 is very similar. So you're asked that P of probability of x that is greater than or equals to a is equals to 0.025. Let's look at where a is, whether it's on the left or on the right. X greater than a to be 0.025. So a has to be here. Now, if a were to be on this side of the graph, then greater than a means to the right of a. Now, if to the right of a, then if it's on this side of the graph, it will be more than 0.5. Okay, so same thing. Now you just use your graphical calculator. You go to stat option and distribution, and then you look for inverse normal. So you select inverse normal. And then you just key in the various data. So 0.025 is the error. Mean of 4, standard deviation of 5. Now your error is on the right. So you select right. And then you will get the answer of 13.8. So this value of a is 13.8, okay? So this is A. In this question, now we have to come to the last part of this video. Now given that x is a normal distribution with mean 50, variance 8, find the set of values of A such that the probability of x smaller than A is greater than 0.6255. Now you notice that there are two inequalities here. Now let's determine where this location of A is, whether is it on the left or on the right side of the bell curve. Now x smaller than A is greater than 0.625. Now that means A has to be on this side of the graph. Alright, smaller than A is greater than 0.625. Because here, if it's smaller than the mean, alright, the mean is 50. Let me write this down. Variance 8. Right, if it's on the left hand side of 50, it will be 0.5. So you want it to be greater than 0.625. So A has to be over here. Let me just shade this area. This area here is 0.625. Okay? Perhaps I just write this down. 0.6255. Okay, this is the area. Now, let us find what is this value over here first. Alright? Maybe I call it B. Okay, B. I call it B. Not to confuse you. So, P of x smaller than B is equals to 0.6255. Let's find this value of B. Now, so I can do an inverse normal. Okay, so I do an inverse normal. Now, so the first thing they'll prompt you is the error, 0.6255, followed by its mean. Its mean is 50, and its standard deviation. The standard deviation is the square root of 8. Remember to do a square root, alright? Then after that, you key in the left hand side, alright? This is on the left, okay? And then what values of B will you get? You will get B to be equals to 50.9. Now let's check. Now if A is on the right hand side of B, if A is here, alright, A is anywhere here, but then you find that if probability of x less than A will be less than 0.6255. So in this case, A has to be greater than 50.9. Alright? A has to be greater than 50.9. Now let's check. What happens if A is over here? Now if A is over here, then you want the probability of x less than A. So you occupy this area here, this part. Then it will be greater than 0.6255. Alright, so this is correct. Now let's do part 2 of the question. You want x greater than A to be equals to be greater than 0.6745. Now let's put P of x that is greater than B, and you want it to be equals to 0.3745. Now, where is this B? Now, then B has to be over here. Because greater than B, and this is less than 0.5. Alright, so B has to be here. So this area is 0.3745. Now let's find the value of B. So same thing, you do an inverse normal. So you put the area first, 0.3745, followed by its mean and standard deviation. And this time you put right. All right, R. Okay, and then what is your value? You will find that your value is 50.9. Same. Okay. Now let's find what is the value, the range of value of A. Now let's assume that what happens if A takes this side, all right, this side. You want X to be greater than A. Let's say A is here. Let's say A is here. Okay. You want greater than A, greater than A. So you find that if it's greater than A, the area here, this area will be less than 0.745. So in this case, A has to be less than 50.9. Now for the last part of the question, you are asked to find the range of values of A such that the probability of X that is greater than A is less than 0.7517. Now let's put it as probability of X greater than B is equals to 0.7517. Now let's find where is the location of B. Greater than B to be equals to 0.7517. Now you notice that this number is greater than 0.5. So B has to be here. Alright, so this is B. This area is 0.7517. So let me just shade this area. Okay. Now let's find the value of B. So you simply do an inverse normal and you will find that, I will not do that again because we have already done so many times. So you will find that B is 48.1. Now you find that B is 48.1. Let's now look for the range of values of A. Now let's say if A is on this side of the value of B, right, this is A. Now you find that if X greater than A, all right, X greater than A, then you'll find that the probability is less than 0.7517. All right, so the value of A has to be less than or equals to 0.7517. Okay, for that we have come to the end of this video. In the next video, we will use what we have learned to apply it to some application problem. We hope to see you again. Have a nice day.